this video, I'm going to give you an introduction to writing equations, and then we're going to talk about slope-intercept form and look at some word problems with slope-intercept form. Let's dive in. So first, big overview. These are the big ideas that we want you to understand. That is that a graph is a picture of all of the solutions to an equation. So we're looking at equations that have x's and y's in them, multiple variables in them. Then they have infinitely many solutions. So you're not just going to be solving for one solution, you're going to be wanting to find all of the solutions. And the graph is a really nice representation of all of those solutions. It also is a picture of the inputs and outputs of a function. The x's are the inputs, the y's that they're paired with are the outputs of that function. And to both graph a line and write the equation of a line, you need the location, which is in the form of a point, and the steepness, which is in the form of the slope. If you think about that, if you were going to tell somebody how to draw a line, you would need the location of the line, where is it on the paper, and how steep is the line. And that's all you need in order to be able to both graph a line and write the equation of a line. So if you can keep that in mind throughout this whole unit, we need a point and a slope. To either write the equation or graph a line, you'll be focused for the rest of this unit. So real quick, let me explain what I just said with an example. So here we have a graph, okay? And every point on this graph is another solution to this equation. So here we have 0, 8. And if I put 0 plus 8, it does in fact equal 8. I have 1, 7, which does in fact equal 8. I have 8, 0, which does in fact equal 8. So you can see every point on this line is a solution to this equation. And the solutions to this equation are the points on this line, vice versa. Okay? Every input here, if I put 8 into this equation, I'm going to get 0 out for my y. If I put 0 in, I'm going to get 8 out for my y. And if I were going to tell you how to create this line, I would need at least one of these points. Maybe 1, 7, maybe 0, 8. I need at least one of these points, and then I need how steep the line is. Now, if I had 2 points, I could also create the line, but at minimum, I need a point and I need the steepness of the line. Last part of the big overview is that throughout this unit, our task is to write equations given various pieces of information. A slope and a point, 2 points, a graph, a table, an x and y intercept, any form of a slope and a point, a slope and a y-intercept. All of these different forms, you have to be able to say, they've given me this information. I'm going to use this form of the equation to write the equation of the line. That's the critical thinking that we're trying to build here, is what information am I given? What can I do with this information to solve the task at hand? And then the second is we're kind of going to go backwards. If I give you the equation, can you tell me the slope of the point? Can you find its graph? Can you tell me 2 points that are solutions on the graph? Can you go backwards from that information to pull out these specific pieces? And that's kind of the big overview. In this unit, we are only talking about linear equations. Linear equations is any equation that has a degree of 1. And there are different forms, which is different ways of writing the equation line. And you can see those forms here. These are all different representations of the very same line. Why do we need all these different ways? Because they provide us with different pieces of information. These each are useful in their own right. So let's first look at that first form here where it's y equals. We call that the slope-intercept form, and it's not a very creative name because what information it provides is the slope and the y-intercept. If you're given the slope and the y-intercept, this is a good form to use to write the equation. M is the slope, it's the steepness of the line, and B is the y-intercept, the location of the line. So if you're given the slope, it goes in front of x, and the y-intercept goes at the end, and it's equal to y. Now, let's take a look at that in word problems. So When you're looking at word problems, some of the keywords for slope are per and each. Anything that's happening multiple times is a keyword for slope. And the keywords for y-intercept would be initial value, additional, flat rate, anything that just happened once. It's just the starting point of the situation, and then we're going to add on or we're going to take away something for each thing that happens. So let's take a look at some examples here. The Lawrence Art Museum offers individual memberships for $49.50. Once someone has purchased this membership, he can go to the museum, I hope this is a discount, for just $5 per visit. Write an equation that shows the total cost y depends on the number of visits x. So here's that keyword, $5 per visit. Okay, if they're going to visit one time, we're going to take 5 times 1. If they're going to visit 2 times, we're going to take 5 times 2. If we're going to visit 3 times, it's going to be 5 times 3. 5 times the number of visits. We don't know how many times, so that's x. And then there's a flat $49.50. That's only happening once. They're only getting charged that once. So that's not multiplied times x. That's just a one-time fee. And then we're going to add 5 times how many times they visited. And that's my equation. So the per goes next to the x. That's the coefficient of the x. And the flat fee is over here in the y-intercept position. Let's look at one more example. Helen is sewing doll blankets to sell at a craft fair. She has 25 spools of thread in her new sewing kit. So to me, that's like ding, 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 ding. That's that initial value y-intercept. And she needs 0.2 spools of thread for each doll blanket she sews. So the differences here between this one and the last one is that she's using up this thread. So she started with 25 and she's using 0.2 spools of thread for each doll blanket, for each. That's going to be my slope. This is going to be my y-intercept. So slope-intercept form is y equals mx plus b. So the b part is 25. She's starting with 25, but she's going to use up 0.2. So that's going to be a negative 0.2x this time because she's using it up. She's going to have 25 and she's going to take off 0.2 for every spool of thread, or for every doll blanket that she makes. So hopefully that gives you a little overview of what we're going to be doing in this unit and a quick introduction to slope-intercept form.